Hello everybody. So these were the 3 problems that I asked you to try, and hopefully you understood how to do it. So I'm going to just write down the answers, and then I'm going to go back over the rules that I talked about in the last video. Okay, so this -3 inside makes the graph go right 3. And this +5 in the back makes the graph go up 5. And number 2, the +5 inside makes the graph go left 5. And number 3, the -7 in the back makes the graph go down 7. So those are the answers you should have got for the 3 problems that I asked you to try, based off of our last lesson when we were discovering with our calculator the different transformations that quadratics can make. Okay, so if you're still confused, I want to go back through the rules. So this is one way of just organizing the information kind of faster maybe than the formula sheet I showed you. So if you have parentheses and there's a plus sign in the parentheses, it's going to make the graph go left. If there's a minus in the parentheses, it's going to make the graph go to the right. So in the parentheses is opposite of your natural thought. So plus is to the left, minus is to the right. If it's outside, then plus would make it go up and minus would make it go down. So that's why all the stuff that was inside was either left or right. So inside parentheses is left or right. Outside parentheses is up or down. So inside is left or right, outside is up or down. And inside is opposite of your thought. Plus is left, minus is right. Whereas outside does what you think. Plus is up, minus is down. So that's why this minus inside made you go right, and the plus outside did what you would think, which is up. The +5 inside is opposite, so left. And this one doesn't even have parentheses. So if there's no parentheses, there's no left-right movement at all. So the minus in the back just makes it go down. So those were some of the things that we talked about. I also want to talk about stretches and compressions and reflections. So I wanted to remind you, let me zoom in a little bit. The quadratic parent, remember, has a 1 in front. So I'm going from a 1 to a 3 to a 7 to a 15. So all the numbers in front are getting bigger. So let's remind what happens with that. Here's the 1 in front, the 3 in front, the 7 in front, and the 15 in front. So see how that graph got skinnier and skinnier? So that's said to be more vertically stretched. So the bigger the number gets in front, the skinnier the graph, the more stretched the graph. So this skinniest one was the y equals 15x squared. Okay, and then likewise, whoa, that was loud. Did I scare you? Did I wake you? Likewise, with this one, the numbers in front, they are getting smaller. So first it was a 1, and then a 1/2, then a 1/4, and then a 1/16. So this time the numbers in front are getting smaller. So here's the 1 in front, here's the 1/2 in front, here's the 1/4 in front, and here's the 1/16 in front. So just reminding you, the smaller the number gets in front, the wider the graph, which we call a compression, a vertical compression. So as the number gets smaller and smaller, the graph gets wider and wider. And then I just want to remind you about the little negative in front. So the little negative in front, all it does is it reflects the graph over the x-axis. So it took this graph of the 1/16 x squared and it flipped it upside down. So it's called a reflection over the x-axis. Okay, so that is just me reviewing all the rules again. This right here, you know, if you needed to pause for a second and write that down somewhere, if that would help you remember, then that would be fine. So I'm going to move on, but if you need to pause me to copy that down, then pause me and copy it down. Okay, so I'm not teaching anything new today. I'm just going to go back over what we've already been talking about. So this is based off of what I taught you in the last lesson and what I just went over. So these say, describe how the following will transform the quadratic parent. Okay, so first, if you see a negative in front, then that is going to reflect the graph over the x-axis. So I'm going to say reflects over x-axis. And if you wanted to print this paper for yourself, you could. I've got it linked on the Canvas calendar. But if you want to just watch, you can just watch. Okay, next I have this 2. So remember the number in front of the x squared for the parent function is a 1. So it's going from a 1 to a 2. So remember how I showed you when the number in front gets bigger, like this one? As the number in front gets bigger, 1, 3, 7, 15, the graph gets skinnier and skinnier. That's called a stretch. So I will say that it stretches by a factor of 2. So this is our normal quadratic parent with a 1 in front, and if the number gets bigger than that, then it's going to get stretched. It's going to get skinnier and skinnier. Okay, then the -1 inside, remember if it's inside the parentheses, does it go left, right, up, or down? If it's in the parentheses, it goes either left or right, but opposite of your natural thought. Plus is left, minus is right. So minus means that it's going to go right 1. Okay, looking at number 2. I don't have anything in front, so I don't have to worry about reflections, stretches, or compressions. So the -3 inside, any guesses? It's going to go right 3. The number in the parentheses is left or right, opposite of your natural thought. And the +4, oh, and sorry, I want to put right 3. And the number in the back makes the graph go up or down, but it does what you think. Plus would be up, minus would be down. So +4 means it goes up 4. Okay, looking at number 3. So I don't have a negative in front, but I do have a 3. So let's talk about the 3. So is 3 a bigger number than the 1 that's typically in front? Yes, since 3 is a bigger number than the one that's typically in front, then that means it's going to stretch the graph. So it stretches by a factor of 3. And then the -4 inside is going to make the graph go right 4. Inside is left or right, but opposite of your natural thought. So minus is right, plus is left. Okay, and then the -6 in the back, that's going to make the graph go down 6. The number in the back goes up or down, and it does what you would think. Plus is up, minus is down. Okay, number 4. I don't have a negative in front, so there's no reflection, but I do have a 1/2 in front. So 1/2, is that a bigger number than the one that's typically in front or smaller? 1/2 is smaller than 1. That means that this graph is going to be wider, which we call a compression. So it compresses by a factor of 1/2. So the smaller the number gets, it compresses the graph. So just to remind you of that, when it went from 1 to 1/2 to 1/4 to 1/16, these numbers were getting smaller and smaller in front. And as they get smaller and smaller in front, the graph gets wider and wider, which is called a compression, until it's almost flat. Okay, and then what do you think about the +2 inside? That's going to make it go left 2. Inside is left or right, but opposite of your natural thought. So plus is left, minus is right. And how about the +3 in the back? That's going to make it go up 3. Okay, good. All right, so I'm not done with this lesson, but this is the first set of work that I'm going to want you to post onto Canvas. I want you to try 5, 6, 7, and 8. So you're going to be doing what I just did. And after you're done with these 4 problems, you're going to take a picture of them and post to Canvas. You're going to have a few more to do besides these 4. So I'm giving you more problems to do this time than I normally do, but they shouldn't take you very long. Okay, so if you need to pause this to copy these problems down, then pause it to copy the problems down. If you're able to print this paper off, you can just print the paper off. So if you need to pause me now, because I'm going to move on. Okay, this page. This time, the words are written down for me. I have to write the equation. So we're trying to write the quadratic equation. So it could say f of x equals, or it could just say y equals. I'll just go y equals. And I want to take the quadratic 1 to the right. So if you ever want to take something left or right, you're going to need parentheses. The squared is on the outside. And if you want to make something go to the right, do you remember what symbol it's going to use? It's going to use a minus, and since I want it to go right 1, it's going to say -1. And then if you ever want it to go up or down, then that number goes in the back. So to make it go 5 down, I'd put a -5 in the back. So now I have written the equation that makes the graph go right 1 and down 5. It's doing what we did on the previous page, just backwards. Okay, this next one, I want to write an equation for a vertical stretch of 2. So if it vertically stretches by 2, that means there's going to be a 2 in the front. It reflects across the x-axis. That means there's going to be a negative in front. And it goes 3 up. Okay, since it does not go left or right, there's not going to be any parentheses. The only time there's going to be parentheses is if the graph goes left or right. Okay, so to make it reflect, it needs a negative. To make it stretch, it needs a number bigger than 1, and 2 is definitely bigger than 1. And then to make it go up 3, then that number would go in the back. And would it be a +3 or a -3? What do you think? A +3 would make it go up 3. And that's the answer. All right, this next one, we want it to have a vertical compression of 1/3, translated 7 units to the left. Okay, so anytime the graph goes left or right, I know I need parentheses in there with the squared on the outside. So if you want it to go 7 to the left, do you know what you're going to have inside? X plus 7. That's going to make it go 7 left. Now, there won't be anything in the back because this is not going up or down. And since I want it to compress by a factor of 1/3, then that means I put a 1/3 in front, which is going to make the graph wider than the parent. So compressions and stretches go in the front, and reflections, which are the negatives, go in front. Left and right movements are in parentheses, and up or down movements are in the back. Okay, so the other part of your assignment is to do these 3 problems right here. So I've got 7 problems total for you to take pictures of and to post into Canvas. Okay, so when you're done with this, you will take a picture of these as well and post in Canvas. And so if you need to pause this so you can get these written down, that's fine. So 7 problems total for you to do. Take pictures of them, get them posted in your Canvas assignment. And that's all for today. Smiley face.